So this topic is about the metallites property. So basically metallites on the periodic tables having a specific property, and they are the elements with property between metals and non-metals. So there is some importance of the metallites, like in industry application, metallites play a crucial role in material science, being integral to the development of various applications, including the semiconductors, glass, and alloys, significantly impacting the technology and the industry. So the key metallites elements of the interest is the boron, which is essential for glass and ceramics manufacturing process, silicon, which is the backbone of the modern electronics and the solar cell, and arsenic, which utilize in pesticides and semiconductor applications. There is some criteria for the classification, like the positions. Metallites are located along the staircase line of the periodic tables, and it's separating the metals from the non-metals. So as a property, they exist characteristics of both metals and the non-metals, such as the metallic lusters and intermediate conductivity. In the physical property, we explore the appearance of the metallites. The conductivity of metallites is understanding their semiconducting properties. So, melting and boiling point to understanding the metallites is temperature characteristics. So there is some amphoteric behavior, like they having the dual nature in chemical reactions. The metal-like properties, like the metalloids, except the metal-like properties when they react with the acid, often forming the salt. So they can donate the electrons, showcasing their ability to behave like metals in specific reaction. In the non-metals like properties, like conversely, metallites can act as a non-metals when reacting with bases, it accepting the electron. This amphoteric nature allows them to participate in the wide range of chemical reaction effectively. There is some typical oxidation states. Like the Köppen states, metallites typically exhibit the multiple oxidation state, often ranging from 3 to 5, reflecting their versatility in forming compound with different demands, different elements. This adaptability make them essential in various chemical reactions. In the stability variation, the stability of each oxidation state varies among the metallites. It influenced by their position in the periodic table. So understanding these states is crucial for predicting the chemical behavior and the compound formation. There is some also reactivity trends, like to analyzing the chemical behavior of metallites. The first is their acid reactivity. For example, metallites typically display amphoteric behavior. They reacting with both acid and base, which allow them to form the various compound depending on the environmental conditions they encounter. The second one is the oxidation reactions. The oxidation states of metallites can vary significantly, allow them to participate in diverse chemical reaction and form a stable compound with the metals and the non-metals alkali, which influencing their reactivity. The second most important property of metallites compound is the understanding their chemical behavior in compounds, like the silicon dioxide, a common compound formed by the silicon and oxygen, is vital in glass making and electronics, so demonstrating the unique properties of metallites in chemical bonding. The second one, arsenic trioxide. Basically, arsenic trioxide, known for its toxicity, is used in pesticides and as a chemical intermediate, showing their dual nature of metallites in both the beneficial and the hazardous application. The other property, which is the semiconductor properties. Basically, the semiconductor behavior metallites like the silicon exhibit the semiconducting property, allowing them to conduct the electricity under specific condition. This unique behavior is essential for modern electronics, enabling the development of various devices and technologies. Silicon chips. Basically, silicon chips are fundamentals to modern electronics. It ensuring the function of devices like the computers and the smartphones. Their semiconducting property make them essential for efficient processing and storage of information, revolutionizing the technology and impacting the daily life significantly. There is some other significant use of metallites like the flame retardant. The metallites like the boron enhance the fire resistance in the material. Some glass making metallites contribute in essential properties to durable glass products. There is some environmental impacts like toxicity and safety. Metallites like arsenic can pose environmental hazards, necessary careful management, so understanding their toxicity and safe handling is crucial for sustainable practice in industry and agriculture.